It's time to review the different types of RAM in a computer system. Now that we understand what RAM stands and serves for, let's discuss the different types of available RAM nowadays. Note that system memory is a huge topic, and there are probably more types of RAM that I could possibly include in this short presentation. Therefore, the main purpose of this chapter is to list the most common types of memory-related terms. Generally speaking, there are two classifications of RAM. The first one is SRAM, or static RAM, and the second one is DRAM, standing for dynamic RAM. When you hear the word RAM in day-to-day conversations, maybe not among your friends, but among other engineers, the term would most likely refer to DRAM. SRAM, on the other hand, is very often referred to as the CPU cache, L1, L2, or L3, as previously discussed in the CPU module. Let's start with SRAM. SRAM stands for Static Random Access Memory and is also known as the CPU cache or the hard drive buffer. SRAM does not need to be refreshed in order to remember the stored data, and it keeps it intact as long as power is constantly provided. This is also why we refer to it as static memory. In SRAM, the data is stored in the state of 4 to 6 transistors or memory cells and requires constant power in order to retain the data. Static memory requires very low voltage levels compared to DRAM. It can store significantly less data, but is much faster than dynamic memory, and therefore it is also more expensive than DRAM. Common types of SRAM include non-volatile SRAM, or NVSRAM, and pseudo-SRAM. Now let's talk about DRAM. DRAM stands for Dynamic Random Access Memory and is mainly used as primary system memory and for the acceleration of video graphics features on modern GPUs. DRAM stores data using pairs of transistors and capacitors, which require a periodic power recharge in order to function and retain the memory, unlike SRAM, which does not require any refresh interval. DRAM is less expensive to produce, but is slower than SRAM. However, it is simpler to replace in the event of failure, or when the need to upgrade a memory arises. The main advantages of DRAM over SRAM are the lower cost of manufacturing and the greater memory capacities. Common types of DRAM include asynchronous DRAM, or ADRAM, synchronous DRAM, or SDRAM, double data rate synchronous DRAM, or DDR SDRAM, Rambus DRAM or RDRAM, cache DRAM or CDRAM, non-volatile RAM or NVRAM, and video RAM or VRAM. We can easily compare static RAM with dynamic RAM using 8 criteria. The first one is usage. The first difference between SRAM and DRAM is the use for each memory type. While SRAM is mainly used for CPU caching, DRAM is used as the primary system memory. The second one is the refresh interval. SRAM does not require refresh interval to retain data, but DRAM does require them to occur periodically. Cost. From a cost perspective, DRAM is much more affordable than SRAM per gigabyte. Density. While SRAM is considered low-density memory, DRAM is considered high-density. Capacity. Due to the cost differences, SRAM is typically used in low capacities, or a few megabytes, while the DRAM capacities are traditionally measured in gigabytes. Speed. Although DRAM allows fast access to data, SRAM provides an even faster access. Relative power consumption. The relative power consumption for SRAM is higher than DRAM. However, the actual power consumption is higher in DRAM. Starting with SRAM, we're going to discuss now different types of SRAM or static random access memories. The first one is the non-volatile SRAM or NVSRAM. This is a type of SRAM that is backed up by a battery, making it non-volatile, and as a result, on a power failure, NVSRAM automatically saves a copy of the data into the non-volatile memory. Then we have pseudo-SRAM or PSRAM, and this is a type of SRAM that has a DRAM storage core combined with a self-refreshing circuit. Compared to the CMOS SRAM, which is the SRAM used for storing BIOS settings and the system time and date, PSRAM has higher density and higher speed. Now we can start discussing the larger portion of memory, which is the DRAM, the dynamic random access memory. So first we have asynchronous DRAM or ADRAM, and this is an old type of DRAM that was used in the first PC builds. It is called asynchronous because memory access is not synchronized with the computer system clock. Asynchronous also means it responds to data input immediately. Now, synchronous DRAM or SDRAM is also known as SDR-SDRAM or single data rate SDRAM. And unlike ADRAM, SDRAM synchronizes itself with a system clock, which means it waits for the clock signal before responding to the user input. And then we have double data rate synchronous DRAM or DDR-SDRAM. This is the evolution of SDR-SDRAM in which the data transfer rate is doubled, which makes it faster and much more efficient. To access the data at high rate, the memory cells are organized into two groups. Each group is accessed separately. This is also the most common type of RAM for desktop computers nowadays. Now, if you have ever purchased a separate memory card, you might have seen the label DDR. And there are some major differences between SDR, SDRAM and the DDR generations, and they have to do mostly with speed and voltage. The speed is usually measured by several parameters, such as the internal rate in megahertz, the bus clock, which is also measured in megahertz, the data rate, which is measured in megatransfers per second, and the transfer rate, which is measured in gigabytes per second. To keep it simple for those of you who are not hardware engineers, keep in mind that speed and voltage are the two major differences when it comes to RAM functionalities. You'll find more information on each parameter's value in the table on the right. Note, DDR5 has been introduced in 2020 and currently supports a bandwidth of 57 gigabytes per second, a data rate of 7,200 megatransfers per second, and a voltage of 1.1 volt. Now let's talk about other types of RAM that are maybe less common than DDR nowadays. So we have Rambus DRAM or RDRAM, and this type of memory uses a data bus width of 8 to 9 bits and provides high data transfer rates over a narrow CPU memory bus. Next, we have the cache RAM or the CD-RAM, and this is a type of DRAM that uses an on-chip cache memory or an SRAM, and in this design, the SRAM acts as the caching mechanism for the DRAM in order to increase its speed. The next one is quite important, and that's the non-volatile RAM or the NVRAM. And just like the NVSRAM, the NVRAM is also a type of DRAM that is backed up by a battery that makes it non-volatile. So as a result, on a power failure, the NVRAM automatically saves a copy of all its data into the non-volatile memory. And this type of memory is commonly used on mission-critical servers. You'll see it on pretty much any type of storage server. And the last type we'll discuss today is the video RAM or the VRAM. And this is a type of DRAM which is used to store visual data for systems display. This type of memory is commonly used by GPUs or video adapters for better performance and 3D acceleration. But focusing on dynamic RAM, we can categorize them into three groups of modules. The first one is SIM, the second one is DIM, and the third one is RIM. You might have heard about DIMMs if you ever bought a separate memory module. Almost all modern computers follow the DIMM standard. So let's talk first about SIM. SIM stands for Single Inline Memory Module and was first introduced in the 80s until mid-90s. SIM modules used 32 bits data paths and supported 30 pins or 70 pins cards. Nowadays, the SIM standard is considered obsolete. Next, we have the DIMM standard. DIMM stands for Dual Inline Memory Module and was initially designed for personal computers and servers. DIMM modules use 64-bit data paths and support 70 to 300 pins. Most modern memory modules such as SDRAM or DDR are designed for the DIMM standard. Laptops use a smaller variant of DIMM called SODIMM. And lastly, RIM stands for Rambus Inline Memory Module. RIM was developed by Intel in the early 2000s as a competitor to the DDR standard and was designed for Rambus memory only, or RDRAM. Due to its proprietary nature, it has never been standardized and is nowadays considered obsolete, just like SIM. Last, let's talk about ECC. ECC stands for Error Correcting Code and is a method of detecting and correcting memory errors on computer storage. This type of memory is designed for mission-critical servers as well, just like the NVRAM, where data corruption or inconsistencies cannot be tolerated. So ECC memory can correct common types of data corruptions or single bit memory errors and constantly scans the code with a special algorithm to detect and correct them. As you can see on the right, this is achieved by adding one more chip on the DIMM, which acts as an error check and correction actor for the other chips.